안녕하십니까. 제18회 세계 해양 포럼.
Welcome everyone to the World Ocean Forum 2024, the second afternoon session. First afternoon session, which is the KIOST session. And this session will be a hybrid session joined by both offline and online presenters. And you can check out the presentation materials at the official website of the 2024 World Ocean Forum. And you can leave your comments or questions too. And channel for simultaneous interpretation, channel 1 for Korean, channel 2 for English. And let us invite the moderator, Director Kim Dong-sung, External Relations Department of the KIOST.
안녕하십니까.
Good afternoon, everyone. We will start the KIOST session, the topic of which is leading policy technology through convergence of marine science and technology with AI. I am Kim Dong-sung, as was introduced, the director of the KIOST External Relations Department. I'd like to welcome and thank all of you to this session. Thanks for joining us despite your busy schedule. And it is my honor to moderate the KIOST special session at the World Ocean Forum 2024. And just like in other sectors, AI technology and AI convergence is getting a lot of attention. So this session is to share with you some of the research results of the KIOST related to the AI technology, and also get some insights for the future. So to start off the session, let us invite President Lee Hee-seung of the KIOST onto the stage for welcome remarks.
예, 안녕하세요. 방금 소개받은 한국해양과학 교수.
Thank you very much for the introduction. I am the president of the KIOST, Lee Hee-seung. So people always say that spring has come, but it is not properly felt. So the same can be said about autumn. So it is well over Ipchun at the start of autumn, but nobody feels it is autumn because it's still too warm and sometimes hot. So I brought my script. So I welcome everyone to this meaningful session in this beautiful season. I'd like to thank the Ministry of Oceans and Fisheries and Busan Metropolitan City and other staff members of the World Ocean Forum 2024. This is the 18th anniversary of the forum, and it has definitely strengthened its presence in the ocean-related issues. And it is all the more meaningful to start this session with the topic leading policy technology through convergence of marine science and technology with AI. So we call good technology a blue technology inspired by nature. And it is time for us to now venture into the ocean under the theme of Blue Revolution, because we can't live on land anymore. For prosperity of the humanity, we must build a new paradigm, which is what we're doing right now. And KIOST, always studying the themes for the ocean, is now searching for topics and themes in the AI technology and convergence. So ocean data is an ample platform of knowledge, not just for monitoring the environmental data, but also for food source and the disaster prediction and environmental solutions. are areas where we can seek further research to realize the potential this grand ocean has. And the AI technology should be a good tool to realize that potential through the convergence of the AI technology with other existing technologies. So in that sense, this session is very, very meaningful, and I hope for the best in terms of the results. So in the future, our technologies and our research that will be combined by new AI technologies and other technologies will certainly guide us through all these challenges to seek for new solutions. And we are all tasked with the questions shared among the humanity to seek for grave solutions, because the ocean has the future of the humanity. Cliche as it is, but is it important still? So thank you very much for the organizer, host of the forum. And I really hope for the best to all the discussants and panelists. And thank you for the presentation in advance. And I truly welcome you again to this session. Thank you.
예, 원장님 인사 말씀 감사.
Thank you very much, President Lee. Now we are going to begin the presentation session, and we have a keynote speaker. So let me briefly introduce our keynote speaker. He is Professor Choi, and he is now KIOST Kim Jae-chul Graduate School of Artificial Intelligence professor, and at the same time, he is also the CEO of ENG. And his research interests include time series data prediction and explainable artificial intelligence. And he was awarded the Prime Minister's medal for his contributions to the spread of AI technology, including improving the predictability of AI and applying AI technology to Pohang's second reactor. He is currently the director of the Explainable AI Research Center at KIOST. And today he is going to talk about the future of ocean technology with AI. Professor Choi, please come up to the stage.
네, 오늘 중요한 자리에서 발표할 수.
It's a great pleasure to have an opportunity to speak at this meaningful event. I feel burdened to speak in front of specialists, and I don't know much about the ocean, but here I'm supposed to talk about the ocean and AI. But the following speakers are specialized in applying AI to the fisheries industry. So if I pretend to know much about that field, it would sound strange to the next speakers. That's why I studied many of the related cases, and I know that you must be familiar with them. But rather, I will talk about my research field, which is the autonomous manufacturing and the operation, optimization, and reliability of AI. And let me start with AI technology trends. And we have technology trends, and especially I will focus on hyper-automation. And as you know, I will also talk about the application of AI in ocean industries. And for your reference, I will also give you practical examples of AI in the manufacturing industry. My research interest includes the automation based on AI, and explainability and stability are very important in the process, and this is the biggest difference. When we do something with AI and when we do something with the existing service, it feels different. And most of the existing services are deterministic, and predictable. And the result should be predictable. That's what we want. For example, we press the button of our cell phone, and when we press the buttons to have the phone number and press the call button, it is supposed to make a phone call. And when we use a remote control at home, the TV is supposed to be turned on. If not, we will feel uncomfortable. And when we use the axle in our automobile, the car should go. This is what we expect from the existing services. However, when we use ChatGPT and when the doctor asks the AI agent, how is this patient? And the AI might give you, it might be the viral infection or immunity issue. I have all these probabilities to give you a prescription. In that case, the doctor would no longer use the assistant service. So when we use a ChatGPT, we expect the ChatGPT would give us something we don't know. So it could be right or wrong, but when we use AI services, even though it is a deterministic, and it will give us the outcome based on our question, however, we partially expect something not predictable. That is why when we actually apply AI services, there is a problem. We have to continue to provide new information. It shouldn't be expected information. That is why the user is struggling from making a new information. And the same pain goes to ChatGPT. And before that, we had a certification and all the documents for the existing services. However, it is not the case about AI. We don't know whether the problem is about the system or about the user. But the easiest way is to make AI explain why it gave such answer. And if AI can explain, it can make corrections when something is wrong. In 2015, DARPA wanted to apply AI to the military. The AI is advanced, but we cannot use it to the military service because it doesn't allow any mistakes. That is why we needed a verification. So for mission-critical system, explainable AI is needed when something goes wrong and how we can fix the problem. So this kind of explainability should be ensured for mission-critical system. There have been various studies, and the development is still going on. And I am the director of the Explainable AI Research Center, and we are supported by the Ministry of Science and ICT to develop original technology. And medical and financial applications are the major areas. And financial application is more about credit rating. And for medical application, the doctors could refer to the AI prescription, and AI should be able to explain the prescription and diagnosis so that we can improve efficiency. And the recent papers talk about AI system, and it make a distinction between explainable and non-explainable AI systems. And the doctors actually showed that there is a more significant result when they used explainable AI. And it is also a mission-critical area. As I explained before, I thought that we lacked research in the ocean field. I have to work with KIOST to apply explainable AI program in the ocean field. We have to publish more papers so that we can apply explainable AI to the manufacturing and financial and even to the internet field. And why explainability is important in the internet? is, for example, to learn Big 3 model, it takes about a day. And but still, sometimes Bixby mispronounces something. So in the process of deep learning, one unit could go wrong, and we are studying how to fix the mistake in the process. And one of our research is it might be the interest of KIOST. So explainable AI has a simple concept. We use AI model, but when we actually apply it, it is not easy. So in the past, we had a device driver before USB, and we installed the device driver, and you must have some experiences. It was not easy. However, USB made everything convenient. The same goes for explainable AI. How can we tune hyperparameters? And how will it be explained by which model? And these complex questions could be the applications of explainable AI. So when we have user data, the rest will be taken care of explainable AI. So it could be Python-based or other types of system. Then we can identify this as image or time series data. So it will recommend the proper system, which will be linked to the provided data, and which explanation is better. So the automatic examination will be done. So for this image, this AI model and this algorithm is perfect. And we also provide open software accordingly. So the accuracy of the explanation and how continuous is the explanation and how concise is the explanation, these are the evaluation metrics. So we apply different algorithms, and you can find algorithms such as RAP and guided credit cam. And based on the weighted parameters set by the user, for this image, RAP is the most desired tool. And this kind of recommendation is made by the tool we have developed. And our project will be examined this year. So please give us feedback after trying this program. I know that you understand how I feel about the upcoming examination. And compactness and completeness are the properties which will be examined. So there are different cats, and how many times did it say it was a cat? And we have some different measures to be examined. And this is the web page of our open software. And OpenXAI is the name of the web page, and you can see the concept, and you can see how to use this tool. And you are still working on the paper. But as I said before, so for example, President of KIOST say, we would like to try XAI. Can you do this? So, and then I say, until when? What is the deadline? And the president says, next month. Then it doesn't make sense because there is tons of engineering work to do. Still, but you can do hyperparameter tuning here. So it is simple to use, so you can get the help when the deadline is urgent. And one more thing I would like to say is that so the World Economic Forum has selected the lighthouse process. You might have heard of it. So in the manufacturing industry, so lighthouse is also related to the ocean. And just like Lighthouse, there are some innovative technologies, iconic innovative technologies. So it is some sort of benchmark, and it is called Lighthouse process. And as they select Lighthouse processes, they felt something at the World Economic Forum. The people collected the data for training, and now we are focused on training the system, but now they are focused on taking action based on the outcome. So in 2018, it was more of the training. However, now, even though there is a failure, they are applying the outcome, and over time, we will see more cases of optimization. So not everything will be optimized, but some high-performing outcomes will go through optimization for sure. So this image, I made this myself. And in the larger context, we build data sets, and we apply algorithms, and we optimize the processes, and we do forecasting, and we make applications. But the purpose is to optimize AI tool. So the ocean industry is not manufacturing. However, in case of manufacturing, the perspective on AI is different now. The build time optimization was key before. But what does that mean? So we have this automobile. So the manufacturer delivers this final product to the customer. And unless there is a recall case, their work is done. But sometimes there are some accidents, but sometimes some people get into an accident. But now we have this autonomous driving system on automobiles, and when they press the button, so they will realize that my fuel economy was not good, or good, or they can realize that I hit the brake faster than others, and they can evaluate how safe they are driving. So I gave you an example of autonomous driving. However, it is called runtime optimization. So for example, when we do documentation, and the same goes for manufacturing. So at the time of production, the user is involved. However, the manufacturer is involved. However, the manufacturer cannot be involved when the product is actually used. However, now the manufacturers could optimize the runtime as well. So as you saw in the previous slide, optimization is possible. We can save energy, and we can improve quality, and we can save time, and we can make our products safer. The AI focused on build time optimization before, but now it is contributing to runtime optimization, and the contribution will be bigger in the future. And I talked about a lighthouse factory, and there are many lighthouse factories in East Asia led by China, because there are factories built by multinational corporations in China and India. And last year, there were 29 lighthouse factories selected, and they present 5 technologies. And they were supposed to explain how these 5 technologies help their process. But there must be 145 technologies. But 68% of them were AI technology. So for example, the battery powerhouse, CATL, was selected as a lighthouse factory. And first technology was AI, second was automation, and the third one is the safety monitoring. So as you see, the efficiency went up by 30%. And for Haier and Danone, they could save energy by almost 40%. I don't know examples in the ocean field, but I believe that AI will be applied more widely in the ocean industry as well. So I believe that I'm skipping this slide too fast. And these are the examples of AI utilization. And predictable analysis system is used for vessel routes. So autonomous operation is possible. But still, we can examine which operation environment is the most optimal when the vessel was operated and which route it took and who was driving the vessel. So now we can power the vessel with electricity, and through autonomous operation, we can lower the carbon emissions. And when I heard the question, when I heard about the issue about LNG ships, so how much energy is used and which route the vessel takes are very important for LNG ships. And I believe that there will be more cases like this. And we have another case in Japan.
그리고 이제
And also in this slide, route planning is important to increase the fuel efficiency, as is seen by the case of Swedish company. So you can see the outcome, how they decreased the fuel consumption by 6.5%, which is, it's boring, right? You know all this. It's already a known fact to you, and I'm just repeating it myself. So monitoring CCTV and marine monitoring is quite similar in terms of AI technology application, or incident inspection, incident detection, and surveillance. They're similar, and of course they can be used differently depending on the purposes. But anyhow, the application will become even more important. And aquatic ecosystem monitoring is also another area. So where our certain fishing stocks are. And one of the areas where AI is used a lot for prediction or forecast is, for example, in the US, through the survey, you can forecast about the harvest of corns or wheat. So ENG researchers take to the field to take a look at the status, to make a report, usually a weekly report or sometimes monthly report.
그러니까 새틀라이트 이렇게 보면서
And we also take a look at the satellite in Latin America to take a look at the growth status of certain fishing stocks or seaweeds, so that we can have up-to-date monitoring data about the factors that can have a direct impact on the pricing. So I think that is an area where we can see some feasible and tangible effect in a short term. Yeah, I'm going to mention the forecast system a little bit more later, and it's getting upgraded constantly. And the demand for steel in China is also live monitored to make forecast about the demand. And recently there was a recent project by the KIOST for the forecasting the demands for mackerel. So I think we're going to see more and more like these projects in the future. Of course, we can't make an accurate figure prediction, but it can be rough, that in a level that is helpful to predicting pricing change or demand change. So it was boring, right? But I'm not an expert myself in the marine-related issues, so I try to add as much spice as possible. But it was boring, and it was right after lunch. So sorry again for the boring talk. And I think I'm gonna share some real case stories in manufacturing industry. So I started this company called ENG, and ENG is a artificial intelligence technology, and the product we make is infinite optimal series. So we pursue ultimate optimal or optimization, and it takes about 5 minutes to walk from my company to here. So I took a walk this morning too. So basic idea is that making good prediction will make a lot of difference. It will be really effective, and part of it could be applied to manufacturing. That is the basic idea. And what we were dealing with in the manufacturing is, I think it's in a sense quite similar to what you're doing in your marine area, in your own expertise. So challenges that we have, they have in manufacturing is that it's really hard to recruit talented people, and environment and conditions are constantly changing, and cost is changing, and so this is a common issue. And manufacturing accounts for 30% of the total GDP, and this is so true, especially in the Northeast Asia. So as you saw, the lighthouse factories are mostly in Asian region. So supply chain and pricing and all these volatility issues that could impact the manufacturing process could be improved by good prediction. So that's why we wanted to use the AI that could be really helpful to manufacturing process, and we're doing a lot of studies. So basically it's prediction and looking into the deep learning process to see what is wrong, and to also explain the decision-making process. And recently, the deep learning, the best deep learning technology was IG made by Google, and Tensor that goes into the technology, but we developed more complicated, sophisticated technology that is better, which we published at this conference. And we also have the original technology for that technology. So the core of what we are developing is this. So there's a set of data, and we monitor these data. And what humans do is to add some human intelligence through the physical modeling and giving more flows or increasing temperature. So we give a little change to that. So it's not 100% automation from the get-go. It's slowly increasing the share of the automation. So AI jumps in to the easiest possible sector, and that it goes up and up until it reaches the highest sophistication. So this is basically to reduce energy consumption and optimize the process, the total process. So I mentioned reducing CO2 emission is important, emission from ship. And manufacturing is also a great emitter, and especially the steel and the fire coal-fired generation. So it's mostly physicality, like you build, you construct, and you also, it sometimes takes really hot furnace that goes all the way up to 1500 degrees Celsius, and cement, petrochemical, and steel are backbone or core industries. You can't just import everything from foreign countries. So if we must do it, then we must find better ways of doing it by optimizing the process using the AI. So one question we can ask here is that we use the AI technology, and for example, there's an autonomous driving car, and if it didn't go through any safety check or validation or any kind of verification, would you drive the car yourself or your family? No. So this is the cement preheater, cement kiln, and it takes a lot of money, of course, to build this, and for those operators of this facility, this machine, this facility is so dear to them. If you operate it like 20, 30 years, it's so dear to you, and you have to make sure that it works fine. And if someone decides that this has to be operated on an AI basis, then you will have bigger concern because you have to make sure that it works fine. So for operator, what AI, they all know that AI is accurate, AI is good, but what really matters to them is that they have to be able to know, they have to have this visibility of how it works to make sure that the machine works. So the kiln that I just mentioned, so the target temperature is 890 degrees Celsius. And well, I was going to show you some video that I prepared, but it doesn't play, I guess. So the red line is the AI-controlled coal, and green line is following the AI control, and the AI is looking for 890 degrees Celsius.
담당하신 분이
And when I said this, that we're going to install this in May, and the operator there says, well, no, it's not going to work because some company with 100 years old of history, they didn't do it, and you were going to do that? No, no way. And at first day and second day, and they see that it is working, then they got really impressed. So after applying our AI technology, they saw the reduction of the fuel consumption, and they were able to use more renewable energies. So they had to worry less about coal or carbon emission. And it also takes a lot of takes a lot of energy to heat steel. So in this process, sometimes you have to change temperature at a certain point. And we had AI do it. It was, of course, better than human manual work. And we also joined hands with SK Innovation to adopt a smart plant in Ulsan factory. And it was the process to produce green diesel fuel. And we replaced the manual work of checking the temperature every 11 hours with the AI technology, with this smart sensor. And we were able to reach the product quality optimization along with the cost reduction that SK was targeting. So our solution definitely helped. So I mentioned the software, open software about the XAI. And the biggest difference is stability. And of course, we don't purposely generate the bug for open software. And we don't do the exhaustible tuning until we make sure that it works 100% fine. But we make sure that it has 95% of stability and also decent level of predictability, so that users can directly utilize the system with their own data and do some experiment and all that. So if you are interested at the KIOST of using this technology, please let us know. And well, this is called the Infinite as I said, the product is called Infinite Optimal Series. So cost reduction is important. And we sometimes buy the heat energy source, or we sometimes sell the petrol products, chemical products. And we also make prediction or help make prediction of supply and demand change. So you can sort of use this technology to make that prediction too. So it's very helpful, and please let us know if you're interested. Thank you.
예, 최 교수님 발표 감사합니다.
Thank you, Professor Che, for a presentation. So we've got tables over there too, but I am not allowed to because we have online participants as well. I have to travel a longer distance every time. And please understand it if it takes quite a while for me to come up to the stage. And now we are going to hear from KIOST experts. First of all, from KIOST, we have invited Dr. Kim Soo-mi, Senior Research Scientist of KIOST, and she received a degree from Seoul National University, and she worked in mostly medical imaging processing. And today, she's going to talk about AI-based machine vision technology for seafoods inspection. Please welcome the speaker with a big hand.
네, 안녕하십니까. 한국해양과학
Good afternoon. My name is Kim Soo-mi from KIOST. Thank you for a kind introduction. Today, I'm here to talk about AI-based machine vision technology for seafoods inspection. So it is about inspection automation technology. And we are participating in a project of inspection automation technology, and let me share some of my research outcome. And let me give you an overview of my project, and afterward I will share my research findings. And this is the background of the project. And I will also talk about the need for the project. When we look at the fisheries industry of Korea, we saw a continuous growth, and there is a growing demand. And the consumption structure is very simple. And there is a change in taste toward more high-priced and high-quality products. However, the production basis is diminishing because there is a declining number of fishing households, and fisheries and seafoods are concentrated in the cities where the fishing is done. However, there are not enough human resources in those areas. So when we go through the processing of seafood, the workforce is not sufficient, but it is mostly done manually, which exacerbates the situation. So we looked at automation and intelligent technology so that we can improve the efficiency of production. And instead of using manual work, we wanted to achieve automation of the inspection system. So our target is smart seafood processing, and in the process, the inspection could be completed in an automated way. That was the target of our project. So this is a 5-year research project, and we started in 2021, and our first phase was completed for the past 3 years. So now we are in phase 2. And in our first phase, we developed our concept and we developed the core technologies. And now that we are in phase 2, we have designated testbed companies. And through these companies, we would like to make our technologies sophisticated so that we can commercialize them. And these are our R&D goals and details by line item. And we cannot apply every technology, and we cannot apply the technology to every food item, so we selected 3, which is a laver, oyster, and fish cake. So automation is achieved for the inspection system. And inspection should be not based on human labor. Instead, it should be based on data. So this is the process of our research. So automation system development and inspection system development are handled by 2 divisions, and technology development is handled by the first division, and the second division is developing a quality inspection system. And Bugyeong National University is leading the first division, and the second division is led by KIOST, my organization. And the second division is handled by KIOST, as I said, and we would like to develop a smart inspection system based on intelligence information. So the processing should be inspected on site. So we cannot do the pre-processing inspection. That is why we focused on imaging inspection because it could be done in the real time on site. So we, for quality inspection, we looked at spectrometry and vision imaging inspection. And we also we are also developing technology to inspect the radiology of seafood. So it has been 3 years since we started the project. And now we are applying the technology to the site. And let me share some of the findings. First food item is a dried liver. And what is the pointer? So this is an example of dried liver, and you can see the wet liver. And from there, we make dried liver and seasoned liver. So we visited the sites and we studied all the steps. And when we look at the processing, there has been much automation. So automation technology was needed for certain steps. So we identified those steps. And for quality inspection, when the weight is not properly adjusted or the thickness is not properly adjusted, it could cause a problem at a later stage, but sometimes it is just released into the market. So because it is done manually, there are some mistakes. So we wanted to develop the automation system for these steps. And this is the application on our test bed. And this is only about quality inspection, and we have various sensors and automated system so that it can be combined to the processing steps without any glitch. And this is the packaging stage, and we figured that packaging stage is proper to apply our automated system. So as you see, the lever is fabricated, and when we have the final product, we can inspect the upper, and we can see both sides of lever, and we can check whether it is a product level quality. And we looked at the thickness or tiltness or foreign material, and these were the examination items we included. And through the first step, we developed this system. On the left side, you can see the vision camera and spectrometry camera. The video was already played, I guess. Yes, it works. So you can see the inspection on both sides, and on the right side you can see the inspection result. So on the left side you can see the result of vision inspection, and on the right side you can see the result of spectrometry. And through this imaging test, we just look at the surface. So foreign material could be detected depending on the size. And now we have a 90% detection rate for foreign material with a 3 millimeter size. And this is the case of oyster. So we box oyster and we package oyster, and we have different steps in between. And most of the work is done manually by human, but we thought of applying our system before the packaging. We categorize oysters depending on the size, and we also do the visual inspection to determine whether there is a foreign material. So automatic screening could be done at the stage of packaging for the purpose of inspection. So this is how to build a test bed. So we have live oyster, and after different processes, we cleanse them, and the cleansed oysters go through the conveyor belt for packaging, and that's when we do the vision inspection as well as a spectrometry. So we check whether there is a foreign material, and we inspect the overall quality of the product. So at first, on the test bed, we verified the performance, and we checked the vision imaging and spectrometry, and we have more than 90% accuracy for foreign material with a 3 millimeter size. And most of the foreign material we have to detect is the shell of the oyster itself, and that is the focus of our research and development now. The third one is a fish cake. So when we have surimi or paste, we fabricate them and we freeze them before packaging the final product. And in the process, we have various types of foreign material. So the packaging for paste is manually done. So, and we tear it off by hand as well. And it could cause foreign material in the paste. And we also have the de-oiling path, and it compresses the paste. And we take care of the de-oiling cloth, every 6 months. And sometimes materials come off from the surface of the cloth and it remains in the fish cake paste. And we would like to detect those foreign materials through our system. So after de-oiling, we go through vision imaging inspection as well as a spectrometry to determine whether there is foreign material and whether it is proper to become a final product. And we have to check both sides of the fish cake. So we flipped the fish cake in the middle of the conveyor belt, and it goes through vision imaging and spectrometry to check the existence of a foreign material. And up to 3 millimeter, we can detect them with 90% of accuracy. And starting with fish cake, we are applying this technology. So we cannot apply this to every factory. So this system is being demonstrated on site, and we selected the target companies. And this is the picture taken at a factory located in Busan. And they are now performing vision imaging tests in their factory. So the video is already played, I guess. So this is how we inspect the fish cake. So you can see the result of vision imaging. But in case of spectrometry, the processing goes so fast, so we cannot conduct a spectrometry on site. So that's why we excluded spectrometry for demonstration. But still, for the purpose of R&D, we are still studying spectrometry as well. This is the end of my presentation. Thank you very much.
예, 김수희 박사님.
Thank you, Dr. Kim Soo-mi. Actually, we do not have a Q&A session for this session. But I think it is boring not to have a Q&A session. So actually, we have ahead of the schedule. So after 3 to 4 presentation, I would like to take some questions from the audience. So I think that's the way I would like to proceed with this session. That's why all of the speakers should be on time.
연안제 안전.
Next, we'll invite Dr. Kim Nam-hoon, Senior Researcher Scientist at the KIOST, and he will talk about AI-based ocean observation and prediction, strategies and applications. He got his degree from Seoul National University, and his expertise is oceanographic system. And he's also interested in AI-based marine prediction and strategies and its application. So please welcome the presenter with a round of applause.
네, 안녕하십니까. 연안제 안전.
Good afternoon, everyone. I am Nam-hoon Kim, a Senior Researcher Scientist at the Coastal Disaster and Safety Research Department at the KIOST. Laser pointer doesn't work, so I'm just going to go ahead with my presentation. So I'm going to talk about the AI-based ocean observation and prediction, strategies and applications. I mostly share my experience and the case that I've been working on. And it's about how to utilize the AI technology in making accurate prediction. This is the content of my presentation. And my title includes AI-based prediction and observation, but I wouldn't call my research as having any intelligence, any sort of intelligence. So I just want to, I think my research is limited within machine learning, and I also personally prefer the term machine learning to AI. So I'll limit my presentation to machine learning. So I'm going to talk about observation and prediction. But about prediction, it would be mostly about numerical model, how to apply this numerical figures into modeling. So in the physics, marine physics, we used data, or we observe to understand the ocean. So as you all know, AI technology is amply used these days. And if you are a researcher in physics, 4 to 5 years ago, they were quite skeptical about using the AI technology. But more recently, 2 to 3 years ago, if I go to academia or academic conference, a lot of physics researchers are using AI technologies. And it's been only 2 to 3 years for me since I've jumped into the AI area. So the oceanophysics, so it works this way. I don't see the point. I don't see the pointer, but I'll manage it. So where was I? So the perception about the oceanophysics, or if you're a researcher yourself, the AI was regarded as a black box area, but I see a lot of perceptual changes these days. So with this perception change, then how are we going to use the AI technology in our research area? And this is from articles that I refer to. So there are 4 sub-areas. Among the legacy technologies, we can use facial recognition to classify patterns of weather and climate, and also hyper resolution technology to improve the data we have, or pattern prediction modeling can also be used to make oceanic prediction. And dynamic time series modeling, it can be based on language translation technologies. So under this big category of oceanic studies, these are the possible categories: observations, theory, models, prediction, and there are also subcategories under each category. And I extracted some keywords under the categories. Of course, this is not an exhaustive list, but what I put into the red box is the area that I'm focusing on right now, and what goes into blue box, well, I'm going to focus later, going forward. So I'm going to focus my presentation from the perspective of observation and prediction. First, observation. The first technology is gap filling. And if you look at the map here, this is the time series data of water temperature. And if you look from 2003 to 2023, you see some gaps here, and most gaps are in summer season. And as you can all expect, there's a typhoon every summer that hits Korea. So sometimes it can harm or damage the facilities and equipment, and it takes time to repair the damages. So sometimes we see these long gaps in data observation. So you got to do something about it to fill the gap. Maybe you can refer to the previous data. You can refer to the history. That's one way. But most of the historical data, they were also impacted by the storms and typhoons and all this seasonal events. So you'll never know what really impacted this data. So it's you become inaccurate in filling this gap. So I wanted to overcome this gap, fill this gap more accurately. So as you see from this diagram, the reanalysis data is built first, and that's going to be matched one-on-one with the real data, and you do the calibration as the next step. So the reason why we do this is that you don't know what was there in the gap, and you still had the system do the machine learning, then you will have inaccurate prediction based on the inaccurate reference. So in the process of learning, machine learning, this prediction that you make to fill up the gap works as a real data. So it's a wrong learning then. So this is how we fill the gap. So you see how the gaps are imitating the real historical data. But this gap actually happened because of some damage to the facilities and equipment because of the storm. So what you see when the storm hits, then the water level rises instantly, and it also reflects that data. So when we implemented the machine learning, we made an assumption that we didn't do the observation until 2020. And if you look at the bottom right, this is the result of the machine learning. And what we wanted to look at is how closely they imitate the historical data. And you can see the gap is filled with close to real data accurateness. But there's a little bit of discrepancy in terms of time. There's a 10-minute difference. And what you see on this slide is temperature. The ERA5 hourling is the data that we used. And if we use higher definition, higher resolution data, then you can see better results here in terms of the filling the missing parts. So we secure the time series data by filling the gap. And what we can do next is to predict the next step. So you first have to build a prediction model, and this is the one-step direct prediction model. And this network has relatively high accuracy. This is not a classic way of making prediction, but and I'll go into numerical modeling. The data and we use this data as a source for L2 domain that we use right now, a KIOST L2, and it has 2 kilometers resolution, spatial resolution. And we did the machine learning for temperature, and convolution LST model was used here. As you all know, it's a very special type of model that is designed for this. And UNIST model is the better resolution model. So the foreign researchers are working on building network, as you see on this slide. And as I mentioned, it has 2 kilometers resolution, and this 2-kilometer resolution is very high resolution. And the change pattern in this grid is very dynamic. And I'm not talking about all the AI model, but when doing some modeling work for prediction, the scaled results you get is sometimes quite smoothened, so you don't get the full pixels, so to speak. So in order to prevent this, we combine the UNN network to convolute L2. And based on this, we had the KIOST do the machine learning on this. And we conducted multi-time prediction. And a little bit about one-step prediction, that what you see on the left is numerical modeling that's used for input data. So to make a prediction, you have to have the data from t-2 to t+2, and t+2 is the result of the prediction. So to make the prediction, you have to take a look at from t-1 to t+1. But for multi-step prediction, when making t+1 prediction, the same happens as the one-step modeling. But for making prediction for t+2, it just does the consecutive prediction based on the t+1 results, which is more right compared to the one-step prediction. So this is quite new. So my focus here is not accuracy, but rather on when using the convoluted L2 network, I wanted to see how much loss we can reduce. So for spatial analysis, spatial resolution analysis, of course, further work is needed. Considering all this spatial bias. So the graph you see on the left is mean bias results. So depending on the time scope, you don't see much difference depending on time scope. But for multi-step prediction, you always have to look for the immediately previous data that you got, so you can see the recursive. You can see more increase or bigger increase in recursive path. So what I've shown you is the one-step versus multi-step prediction using numerical data. But another research is going on about calibration. So predicted data and observed data are both learned by the system, and maybe they can be combined to create another set of data that can be used as a source for another system. So, but I want to limit my talk to the prediction only. So utilizing the observed data or the predicted data for prediction or a numerical data has limitations, either because of the lack of spatial data, or because of the lack of accuracy, which is inherent to prediction. That's why we're using hybrid modeling in prediction area. So in the process of developing original technology like algorithm, what we can learn as a takeaway message is increasing accuracy of the predictive data. And so what we need further is computing resources. So our CPU is big, of course, but the AI has a lot more parallel CPU, GPU, so that we can secure more accuracy in prediction. So hybrid modeling would be the answer going forward. So that is the conclusion of my presentation, and thank you for listening.
예, 김 박사님 발표 잘.
Thank you very much, Dr. Kim. Next is
해양
Let me invite Dr. Jo Hong-yeon from Marine Big Data AI Center of KIOST. He will talk about standard process and practical barriers, limitations for an AI model, and ocean science fusion research. It is a long title. He received a doctoral degree from the Seoul National University, and now he is developing models for the maritime sector through diverse researches. And if Dr. Cho's presentation is finished on time, we will take some questions afterward from the floor. Please welcome Dr. Cho with a big hand.
안녕하십니까.
Good afternoon. My name is Jo Hong-yeon from KIOST, Marine Big Data AI Center. So I thought about which theme I would go for with this presentation, and AI is a huge theme, and there are some presentations about AI in general, and there are some presentations about case studies. So I prepared something in between. So it is a bridging presentation. So when we take one step further, I believe that specialists could study on their own. However, I believe that you can learn some new terminology here. I think that will be meaningful enough, because if we give you too much of a general presentation, you will learn not many things. So AI model is a broad term. So I develop models, so I will focus more on AI models. And what is AI model? And how can we use those models? So experts can use models on their own, but if you are not an expert, you can understand the standard and procedures on how to use the model. And let me introduce myself briefly. I received a doctoral degree in 1994, and I developed models. So is it a big feature in science? But I have originality because I developed something new, and it was a model to measure water quality. So you might think it is one model. However, to do that, you have to develop a model for hydraulics, and for water quality, you have so many reaction coefficients. So that is why, for optimization, I developed an automation model, and the edge was a square, so I did greedy generalization. So all of these processes were included in my procedure for developing a model, but I've never used a model afterward because it was not competitive enough. However, in case of a bigger model, individually developed model can compete. So it was the background for my water quality model. And after joining KIOST, I developed a model for ecology. And recently, one of my teaching areas is marine engineering. So it was mostly about WOF. But when I was in my sabbatical year, data statistics is something I learned. And coding is also important, as well as statistics. So I studied data analysis, statistics, and coding, and I am teaching those subjects to the graduate school students. So let me speed up. So I will talk about what model is and what modeling is. And when we say model and modeling, what are the proper steps and what are the limitations in AI, ocean science, fusion modeling? So everyone can understand what model is simply. The user makes an input and the model gives you an output. So function is the simple format of a model. So we just give a number and it gives out a result. An AI model is the same. The user asks a question and it gives an answer. And that is the AI model we are referring to. And model and modeling are different, just like a market and marketing. The modeling is all the processes of this model. So it is similar to the difference between the soccer and soccer ball. So you kick a soccer ball and you play soccer. So there is a difference. So for AI model, we have a well-known ChatGPT, and researchers mostly use machine learning model. We have a categorization, regression model. So it might sound unfamiliar, but you have to learn something new. So I'm giving you these new terms. And we have a traditional numerical model. So physics is not everything. However, we always start with the movement of the water in ocean science. That is why we have to look at the physical aspects. That is why we have to learn differential equation. And how can we converge this area with AI? And this is what we have been studying recently. And let me give you some premises. Model is a tool. Model and engineering, there is a relationship. Engineers make a model. The model is a tool. Please keep this in mind. And there is no almighty model. It's a wishful thinking. There is no almighty model which works in every field. The same goes for human. We cannot do everything well. And even though it is not written here, it is garbage in, garbage out, and gold in and gold out. So depending on the quality of input data, the output data quality becomes different. So let's look at the models in the ocean science. So this is based on my experience. So there are multiple models. So we have a model based on differential equation and simply based on mass. And we have the tidal model, wave model, tidal flow model. And we even have a broader model such as a climate change model and pollutant spread model and reaction model. And for biological model, we have the ecological model, including red tide model. And the simple equation is the mass conservation model. And we have fish models as well. However, we cannot run the model because we do not have data. There is a technology, but we do not have sufficient data. So let me move on to the modeling steps now. The first step is, what is it? What will we do? We have to define what we are going to do. So modeling is a concrete action. We cannot say, oh, we are going to use this model. So for example, I would like to peel off an apple. In that case, you need a knife. You cannot bring any random knife and what am I going to do with this knife? It is not going to work. So you have to define what you want to do. And in ocean science, so what do you want to calculate? That would be the first step. And what about the second step? You have to select the model. So there are diverse models around you and you have diverse tools around you. So you have to browse and select the proper model. And before that, you have to define what you are going to do. And the second step is a selection of a model. So we have a model CV for each one, and models are evolving. So a decade ago, the model couldn't do anything. However, it must have evolved over time. So you have to look at the CV once again. I stopped developing model at some point because everyone is using the existing model. However, when there is no available model for their purpose, sometimes I'm asked to develop a model. Then I can send you a quotation right away. I want to do this and I need a model, and I can just calculate how long it takes and how much it costs. So you can select a model, and if there is no available model, you have to develop a model. So this is still at a setup stage. And the next stage is a headache. It is a test phase. It is a calibration, verification, and validation, and training and test and performance test in terms of a machine learning. And these are done by experts. So within the model, whether it is working or not, the tests are performed by experts, but it is not a something visibly rewarding right away, and it takes a long time. However, it determines the power of the model. So other people might not realize, however, the model, which is trained for 3 hours and for 300 hours, the performance will be definitely different, even though it is not visible on the surface. So for non-modelers, they could be easily deceived if experts do not tell. But you have to rely on the conscience of the model developer. However, many people give up at this phase. But experts do the testing on their own. So you have to trust the capacity and capability of the developer. Yes, this is the test phase. And after setting up the model, and if it is working fine, we will move on to the application stage. And the most powerful model can calculate everything depending on input data, and they can secure a certain margin of error. And even though it is an environmental and ecological model, which is very general, still it can calculate most of the imaginable questions. So it is called a simulation, but in virtual space, a calculation is done. So for application, model is fully ready, and it is time for us to use the model. But we have AI models and ChatGPT models. What is going to happen with them? So we have limitations for now. So it is not based on theories. It is based on probabilities. So it has the role of a majority. But for hydraulics, so it is about dynamics. But there are some probably possible facts, which is black box. But the model cannot predict everything, but you can still use both of the theory-based model and probability-based model. And these days, we have a complex model, just like a car. But we have car parts, which are sub-models, and we also have the supporting models. So when we look at the ecology, for example, we have a red tide model, but it looks like an ecological model, but we have to calculate the tidal current first. So the red tide model is not a single model. It consists of various models. So we have to work as a team. Not a single person can do this. The red tide model is done by a modeler. So the study itself can be done by biologist. So when we think of a traditional model, numerical model comes to your mind. Physics and biology and chemistry, they are all using numerical mode, and we have a new types of model, which is AI model. So how much data we have will determine on which model we can use. So if we have sensors and satellite image, we can have big data, and physics is related to big data. So numerical model is strong in physics, but what about the environment and ecology? Numerical model is not working, and AI model is not working because there is no enough data too. So this is the end of my presentation. So before ending my presentation, I would like to say that there is no most powerful model for every area. So don't be afraid of AI. You can carry on with your job. So for the past 1 decade or 2 decades, people said so many scary things about my job, but it was fine. So with the hybrid model, we might create a monster, but if everything works out, we can make a proper model. First of all, you have to define your problem and prepare reliable data, and you have to ask for data from a reliable source. So define first. That is my key message, and this is the end of my presentation. Thank you very much.
예, 주 박사님 감사합니다.
Thank you, Dr. Cho. It was such a passionate presentation. So I knew that he was going to use more of our Q&A time. So from now on, we are going to take some questions from the floor. So you can ask questions to the speakers. So feel free to ask questions. We will have a Q&A briefly. So please raise your hand if you have any question. We will deliver a microphone to you.
최은우 박사님
Dr. Choi,
하는 거 아니에요?
you've got a question?
질문 있으세요? 예, 조 박사님. 예, 저 잠깐 마이크 저기 있으니까 두 분 다 마이크 받으시면 돼요.
아까 그 자동 생산 공정에서 얘기해서
So you mentioned
So traditional automatic control and AI control are different. May I explain them? Could you explain that? So I missed out on something. So traditional control is based on linear model prediction. And even if it is non-linear, it is based on a simple model. But when we developed an AI model, in the process of modeling, we used a lot of AI technologies. So if we make an input, we can just get an data, we can just get an outcome. But data based on accumulated experiences is the best input. It worked the best. However, the structure should be there for AI model, and we have to feed training data so that AI could learn the structure itself.
실에 뭐 사이클로트론 이렇게 6개가 있고 뭐 원료는 이쪽으로 들어가고 온도는 저쪽에.
so there's a preheating pump and the fuel comes in here. So the AI takes a look at the correlation between all the process. So the traditional model only focuses on the specific process target, but AI takes an overall look at the process. So it's just like autonomous driving. And of course, there's an exceptions. Sometimes, for example, on a highway, sometimes there's no lines, or sometimes it rains. So there are always exceptions that have to be considered by the AI technology. We can't define everything in advance, but it is important to clearly let them know that some areas we can't manage. Well, this is the area that we can do, and this is something we can't do. So we have to have a clear definition of the scope. So we'll take one more question.
일어나서 말씀해 주시면 더 잘 보일 것 같아요.
Okay, thank you so much for the
Please stand up. Please stand up.
great presentation today. My question is for Mr. Cho Hong-yeon earlier. Okay, earlier you mentioned about the verification of your model. So my question is, what about if the result is not working? Let's say it's overestimate or underestimate. So what kind of improvement that are you doing to make it better? Thank you.
So prediction problems.
No, I mean like for your model, you said you do the verification for your model.
Yeah,
And then
verification. Yeah.
how about if the result is not working? Let's say it's underestimate or overestimate. So what kind of improvement that are you doing to make it better?
Anyway, the model is underestimate or overestimate. You should check it is acceptable or not. Is it tolerable? Are you acceptable? Yeah, acceptable or not. It your own criteria.
So you make it, I mean like if you check it, let's say it's overestimate with the...
By using the monitoring data or some reliable data.
I get
And
it.
because of this, data is really important.
Okay, so it's depend on the initial condition, you mean?
Yeah,
I get it. Thank you so much.
you're welcome.
예, 아주 좋은 질문과 좋은.
Thank you for a great question and great answer. So there must be more questions. However, we have to move on to the next presentation.
저는 키오스트의 해양위성센터 유지영.
Next presenter is Dr. Ryu Ju-hyung from the KIOST. Dr. Ryu is a principal researcher scientist at the KIOST. And Dr. Ryu got his degree from Yonsei University. And he has an expertise in oceanography and the mud and the stationary orbit satellite. So please welcome the presenter with a round of applause.
네, 안녕하세요. 해양위성센터.
Good afternoon, everyone. I'm Ryu Ju-hyung, and what I'm gonna talk to you about is blue technology. I learned about the concept quite recently. So there's been a research on the mud ecosystem, and what you basically do is you go there with a shovel and all this device, and you wait until the tide goes off, and then you collect some species, and then you have to crawl out of the mud with all the mud in your backpacks. So mud, we have this Korean expression 벌지, which refers to the things that you do with to no avail, and you make a mess, but you don't get much out of it. So you go to the mud flat and you see some holes through which some species poke out. So you put a shovel in the hole, and in most cases, you get the animal. And if you're an expert biologist, you see a hole, what it looks like, and you kind of guess what the animal would be. So what if we can take a photo of this mud flat with holes in it and have the machine learn what species are lying in these holes, then that will be phenomenal, right? So that's the basic idea of my study. So Korea has 2.5% of its land as mudflat, which is larger than 2,000 square kilometers. And mudflat is also a great source of economy because it produces animals, something that we can eat. And we have some mudflats designated as the World Heritage by the UNESCO. And China and the US have their own mudflats, but they only protect the area. They're not designated by the UNESCO as the World Heritage. That's the difference. And the 4 mudflats in the Korean Peninsula, all of them are known for aquatic aqua farms. So they're a great source of protein. And this is the background of my research. So you see 12 holes with different species that could be lying or hiding inside them. It's very, very small, like 1.62 centimeters small. And well, you can use drones, of course, but drones have to fly very, very low, shorter than 5 meters high. And the resolution must be super high to the level of 1 millimeter. So it was really hard for us to take a photo of this. And we have our own know-how. So we build training data and we set machine learning data. We get the data and we put the data into a system. But this is the direction of our research. This is the target of our research. So in order for us to be able to do that, we need to have a good learning data. So we have to build a data set by taking photos and inputting data for each hole and everything. So we recruited some part-timers, but it turned out we needed experts because any random part-timer students or any non-researcher, non-experts can't pick up all the holes. And as you can imagine, it's really physically demanding. You need to have a good eyesight to identify all the holes. So it takes time, it takes money, it takes a lot of people's work. So we easily talk about using the AI technology, but before using the technology, we have to make sure that this is done as a precondition to work that's going to be used by the AI. So we are continuously improving our data quality. So in order to be able to know the species for any specific hole, or to know the population of any species, what we do is to use the AI technology that will be added to the existing biology. So if you look at these crabs, you can see how their claws are quite big. And by looking at the size of their claws, you can make a prediction of the size. And another thing is that these crabs move. Sometimes they throw away, they desert their existing hole to move into another one, the new one. So this is the picture that we envision in our head. So basically, you need to have the species with the size of the species. Well, sometimes you get this delusion that AI will do everything for you. You don't have to do any manual work. So that's the world that I truly envision, that I truly dream of. I don't want to do any more manual work, but that is impossible. We have to do all this budget, all this manual work. We have to go through all these hassles, and it takes a lot of time. Takes a lot of money, of course, for designing the AI technology that will be more accurate, that will be more that will do more work for us. But what we are thinking for a more efficient monitoring system. Well, if you look at this slide, the mudflat, any mudflat has a very, very small gradient. Well, it's not very sharp. It's not very big, big gradient, but very, very small gradient. So, and you might have taken as some sort of blood vein, but no, it's actually the way of wave, flow of wave that's in the mudflat, that's beneath the mudflat. And if you look at these vein-like lines, you can kind of predict the conditions of the mudflat. So, for example, this area is a little bit higher than the right side area. Again, the gradient is very small, but it has some differences. So the water touches the left side area quite later as compared to the right side. So there's going to be some difference in water density or water level, for example. So you can get a lot of data out of this simple picture. And you can see the legend here, 10 categories of color coding. And this is the result. Well, if you do it manually, it usually takes about 3 months to get this result. And even if you use drones, you won't get this level of resolution. But you will have like 75% of accuracy, at least. So you can know like geography or the composition of the land, whether it's sand or whether it's mud, then you can pretty accurately predict or know what kind of species are living there. And also because of the salinity, the species that are living there might be different. So usually you use 3 factors. You need 3 factors to make a prediction about the habitat or ecosystem of any certain section. So there's this line, and if you capture this with high resolution of 5 meters, for example, and you can see you can get the data from this and take a snapshot like the ones that I showed you. So what we have is high resolution. That is 1 millimeter level, and we also have the satellite that can take photos at different altitudes. And this system can be used for different purposes. It can be used for coastal monitoring or ship monitoring or mudflat monitoring. So our aim is to build this comprehensive system or platform that can be used in many different ways by humans to suit their purposes. And we conducted a literature review using the Chanlian satellite that we have. And it's been up there since 2010. And 500 papers were published. 500 articles have been published using this satellite data since 2010. And 30% of such papers used AI technology, and that percentage goes up if you come more recently to 50%. So it shows without AI technology, any kind of analysis will be impossible. So the resolution from 1 millimeter to 250 meters, the system resolution could be different, it could be diverse, but it has only one aim. Can it allow us to see what we want to see? And the research must go on to reach that target. So one difference of using drone is that all the process became so simple. So you only need one drone and batteries, the spare batteries, and coffee dripper. So all you have to do is, put the drone to fly, and then you drip the coffee and you enjoy your coffee until you have to exchange the battery. So that's all you do. So this is how conveniently we do the research these days. So thank you very much for listening to my presentation.
예, 유 박사님.
Thank you so much for the presentation, Dr. Lee. Liu. And next?
예, 박사.
Now we are going to invite Dr. Baek Seung-jae from KIOST, who will talk about the polar region communication technology and equipment for Internet of Extreme Things. And Dr. Baek received a degree from Dankook University with computer science, and now he's studying convergence studies. Please welcome Dr. Baek with a big hand to the podium.
예, 안녕하십니까.
Good afternoon. As introduced, my name is Baek Seung-jae. So today I will talk about the polar regions. So for this kind of polar region, we have the proper communication technology, and I will introduce this technology. And it might be a little bit off topic because AI is scantily involved in our work, and it is more about communication. And communication is mathematics, and it is standard. So it is not visible to our eyes. So I believe that it is at 3 o'clock. So you must be tired, so I will use a lot of visual aids in my presentation. So what was the direction for our research? So in the past, in polar regions, there has been study on geology and marine ecology. There were 3 challenges which are written on the left side. So data collection was the first challenge for them. So satellite communication could be one solution. However, given the characteristics of the polar region, when we think about the trajectory, there are not many chances to smoothly run the communication. And even though the communication system is working, it costs a lot to deal with a vast amount of data. That is why people went to the observatory themselves to secure and retrieve data, both in Arctic and Antarctic region. And the second challenge is about observatory. So there are devices which stay healthy until the end of its life. We have to calibrate those instruments from time to time. The same goes for this challenge. People go there in person. And data collection is done by humans. We have to go through crevasse, which is a high risk. And third challenge is observation period. In polar regions, we shouldn't leave even a drop of oil. That is why we need eco-friendly fuel. So it is minus 50 degrees Celsius there. So we have limitations in the use of batteries. So on the right side, this is the direction for our research. So the data from the observatory could be transferred to the base station, even regardless of the amount of data. And the second direction is to maintain observatory through robots instead of humans. And the third direction is to develop a dedicated battery for the polar regions so that we can sustain the observation period throughout the year. So please have a look at the bottom of the image. So you can find the station, which looks like a triangle, and that is a Jangbogo station. And we have base stations around the observatory, and we retrieve data on astronomy and ecology. And robots are roaming around in the polar regions, and their maximum moving range is 50 kilometers. So we have observatory and base stations and observation points, and the communication among these 3 points is the subject of our research. So when we look at the current situation, there are some treaties on the studies for polar regions. And in case of COPRI, they collect the data and analyze the data. And KIRO develops a robot for polar region exploration. And my organization, KIOST, is developing communication and equipment. There are so many fine letters, so I'm not going to read everything, but I will give you key points. The robot developed by KIRO can be distant and the maximum range of 50 kilometers from the observatory. So even 50 kilometers away from the observatory, they would like to have the communication at 10 Mbps That was their request. And they also need IoT device and gateway for the polar region. And we also need the communication and network between the wireless control station and wireless control station between these stations. So this is the wireless backhaul network we have to develop. So on the right side, there is the requested specifications, but it is requested by the users, so we have to conduct a feasibility study for the specifications first, because there has been no protocol for communication around the world. And my organization, Marine ICT Mobility Research Unit, developed this vision, as you see in the graphic here. And we wanted to develop the wireless communication for monitoring and even the underwater communication system. It has been another research topic we worked on. And we can tailor the IoT for the ocean. And we have been building the standard platform called IOMT. And as you see in the slide, from different sensors, we get the data through multiple interfaces, and we have gateways for these interfaces, and we have technologies to upload the data to the server. And we conducted the testing, and we confirmed that the data is transferred to the base station on land. But long-range communication is problematic. And now we are using LTE or cellular network to the land. However, when there is no base station on land, how can we deploy communication? And this is what we did. We used a directional antenna. So we tested this one on board, and unlike on land, boats are moving constantly because of waves. So between the antenna, the communication constantly experienced glitches. So you use a gimbal for a stable picture. So we made this gimbal dedicated for antenna. So as you see in the picture, even the boats were constantly moving. We could have a clear and stable image. And the reason why I talk about this research is that we wanted to check whether the specifications requested by the user were feasible. And we determined that it could be feasible. So I have so many words here instead of pictures. So let me give you a summary. So between robot and base station, we need communication. And second point is that we need antenna and gateway and devices which can be used in the polar region. And third one, the control station and base station, they also need communication between them. And in the middle, that item could be feasible when we make a lot of efforts. However, the first and third items were hard to materialize because we didn't have a communication protocol with these specifications before. And for communication development, we need a certain number of parameters for setup. We have to set up the frequency and what is the curving point, and these are dependent on the surroundings. So when there are many buildings, the parameters will be different. And for example, when we are in the ocean, there is wave and water, so the setting is different. And in the polar region, we have a multi-pass because of snow, so it is a different environment from the ocean as well. So the traditional setup cannot be used. So that's why we have to take measurement on site for a parameter setup. But if we have to go to the polar region, take measurements and come back and experiment in the lab and go back for installation, it takes 3 years. That's why we looked at the quality of snow and we used deep learning to analyze the characteristics so that we can satisfy the specifications requested by the users. So let me talk about the outcome. So we developed devices and gateways which could be used in extreme weather situation, which is below 50 degrees Celsius. It is resistant to shock, and it should stay longer in extreme weather, so it can be heated in both of a passive and active manner. So for passive heating, we can put it in a packaging material, but for active heating, it can heat itself when the weather is too cold. And for antenna, you can see the snow will mount on top of the antenna in the polar region. Then it will glitch the communication. So we thought about the shape of antenna and we analyzed the structure. And do you know the golf ball? You can see some dimples on the surface of the golf ball, and we adopted that design to the antenna so that there will not much snow on top of the antenna to avoid the temperature and weather issues. And the third item is a battery. So you know how important the battery is. But in the polar region, it is hard to move around. If you are moving around with a battery pack, you have to take a break every minute. So we needed insulation, and we made a modular battery pack so that it can be replaced easily. And we tested them in a freezer. It remains heated. And when there is too much electricity used, we need to cool it off even. So that means that it is heated very well. So by using AI, we set up the parameters for communication. And as I showed you in the slide, software beamforming was not possible, but we made it possible through our system. And we started with a domestic system, and you can find the 3 pictures here. And on the upper left picture, this is the test between Deokjeok-do Island and Changbong-do Island. And next to it, we had a test between Deokjeok-do Island and Seongmo-do Island, whose distance is 52.2 kilometers. And we were confident after these 2 rounds of tests. So finally, we ran a test between Jindo Island and Jeju-do Island. So your Wi-Fi you are using at home can be both present, both in Jindo and Jeju Island. You can use this system in your office, then you can use the same Wi-Fi at home. So after testing, we went to the Antarctic area. So you can find the Jangbogo station, and at 2,800 kilometers above the land, you can see the peak of the mountain Everest. And we built base stations for observation, and around that, we also installed observatories. And these are actual pictures of a mountain Melbourne and Browning Pass. And you can see the equipment being installed. And Jangbogo Station and Browning Pass look close in the picture, but they are distant. So the researchers went uphill and they brought the battery cell up one by one, and we tested whether the communication was working, and we could satisfy the specifications successfully. And we didn't expect this high level of success because the parameter setup was much more smoother. much smoother than expected. So I believe that we can achieve more out of this project. I think my time is up. And I talked about the development of technology based on specifications requested by the user. So we looked at priorities on the roadmap in the polar region that is meaningful, that shows the significance of my research. Thank you very much.
예, 백 박사님 발표.
Thank you, Dr. Beck. And let us move on to the last presentation.
에너지 연구부의
Last presenter is Dr. Han Tae-ki, Principal Research Scientist of the KIOST, and the theme of his presentation is development of technology and for establishing an underwater data center complex. He got his degree from Korea University, and he's been conducting the underwater data center currently. Please welcome the presenter with a round of applause. Good afternoon, everyone. I am Han Tae-ki from the KIOST. And I am going to talk about underwater data center complex that we're working on right now. And AI technology is developing, which will be used a lot more. And of course, big data. And computer servers need to be big. And the power usage will be increasing too. And you hear that all the data centers are consuming a lot of power. We will need more power, and Microsoft is building another data center and servers. But we thought maybe we will build or develop technologies that will consume less power. And underwater data center is based on such an idea. These are the contents of my presentation. So heat radiation of underwater data center and feasibility of building the complex and the summary and recommendation. So as I mentioned, demand for data center is increasing, and it will even grow in the future. And 20% of the total power used in the ICT is consumed by data center. And we see the same trend in Korea. And we see more than 34% of the growth rate of the data center as of 2024. And the carbon emission from these data centers are huge because it's, as of 2020, it's more than 200 million tons per year. So we thought, as I said, maybe we need data centers that consume less energy and that emits less CO2. So ICT consumes 20% of the total power for their data centers. And this is mainly for cooling the machine. So when machines are operating, they generate heat and they need to cool down the heat. And if we can control this heat, then we're definitely going to need less energy. So hyperscale data centers are what we are talking about. These hyper data centers have more than 100,000 servers. And another issue here is that all these data centers are located in or near capital areas. So there will be a concentration of power and the too much loading, excessive loading of energy. So people sometimes talk about distributing the data centers to local regions. So you need air conditioner to cool the machine, to cool the servers. And SK is talking about liquid cooling, and Microsoft suggested underwater cooling, and they conducted testing. And in China, Highlander built a underwater cooling system, just like Microsoft. And Microsoft completed third phase testing in Scotland, and they disassembled all the machine. And during this phase, there was no error, no failure, and they saw 1/8 of the power consumption compared to the existing method. There's one case, Highlander saw one case of failure, and it was during the physical delivery of the machine. Other than that, there was 0 failure cases. So there's this cooling pipes that weave through the servers and server lines that ultimately cool the lines. And Highlander Highlander changed the flow of the coolant direction. They flip the direction regularly, and that's how they achieved efficiency. And this is the basic model of the cooling system. So there are 3 modules. And what is different than the previous Aquarius of the US is that the previous model was to make sure that it remained underwater for as long as possible. So the pressure, they had to care about the pressure, pressure that has to stay the same as the water pressure. But our model is operated under the atmospheric pressure. And it also has the ventilation system, just like this space station. So oxygen is being created internally. And on the left side is the data center module. And in the middle is the cooling module. So this is the possible underwater IDC complex. And this is how we will do the heat, radiation, and cooling. So you see there's no pump, but we only have housing and the flow of water. And sometimes you use seawater. The one option is to use the seawater, and the second option is to use another type of water that's provided from outside. So the first option is to use the heat exchange, an internal heat exchange, and then you create a sort of heat radiation or heat convection inside. And so sometimes when you have to get the water out after using it as a coolant, sometimes you see the clogging. So in order to address that issue, we just thought of using internal water without having to let it go out. So you see this circulation pipe, and heat exchanger and the server racks here, so you don't have to think about the clogging problem anymore because water circulates inside. And this is the heat radiation through the pipes. So hot air stays up and cold water stays down, so you have to make sure that they mix so that convection happens. And so to make heat exchange happen, you have to make sure that the hot air and cold air gets mixed. So this is how it is created. And this shows how heat exchange happens to cool the machine down through housing. And it shows it could be how it could be more effective under a certain flow speed. So you see the water comes in slowly or fast. It becomes faster going down, and you see the cooling down happens in a speedier manner. So if you go from up, if you go to the bottom, you see the speed gets higher. And this shows, this also shows the current speed and direction. So this is the result of our experience. So flow speed above 0.2 meter per second can be considered a critical factor where the limit of seawater heat transport is reached. And direction is not significant. So heat radiation and housing and heat exchange is the only thing that's happening. And we compared underwater installation and on-land installation. The left and right is the different location of installation, and you see the difference of cooling. So you can also see the difference between summer and winter, and you can see the underwater cooling is as effective as in the winter. And we also increased the land area. And you would all know that if any area gets bigger, then the exposure gets bigger, so it cools down faster. But in our case, it wasn't as significant as we expected. And this is the pipe. So the results that we got show that heat exchanger is needed to secure more effective internal water cooling down. So we're talking about data center complex, not just one data center. So we are talking about 5 meter by 10 meter pod. And in the pod, there will be 24 racks, and there will be 960 servers per rack. Then if we do all this calculation, then this much money will be needed, this much weight will be required. And this shows the feasibility of building the complex. And how we're going to do it is to assemble all the sets on land, and then we submerged it later. And this is the construction cost. We worked with the GS construction company to do the calculation, and the results is in the left bottom. So 130 billion won will be needed, all in all. I'm sorry, 113 billion won will be needed. And if you look at the right side, this is the comparison of the construction costs between the underwater data center complex and the on-land data center complex. And Kakao and Naver have their data centers. Another thing for the on-land data center is that they have to secure the land too. So what the figure you see here is only for the construction cost. So that does not include any cost for renting the land. So underwater data center will be much, much cheaper. And this is the required items to be checked. And this is the economic impact by building underwater data center complex. So this slide is my last slide for summary and recommendation. So I uploaded all my presentation slides to the ChatGPT, and this is what it came up with. So you can see the results here. So thank you very much for the attention.
예, 한 박사님 발표.
Thank you so much for your presentation, Dr. Han. So we listened to all the presentations, and of course, we'll take a question, one question only. Any question, comment, raise your hand, and we'll get the mic to you. Yes, please. Dr. Zhang.
예, 저 마이크 좀 갖다 드리세요. 간단한 질문과.
Please be brief. I had many questions for Dr. Chung, but Dr. Han just delivered a presentation, so I will be brief.
So chamber is a little bit away from the land. So what about the power provision? It must have internal generator inside, right? So and for a module, for 3 modules, internal generator provides power, right? Then what about the delivery of other necessities for people working there, working in the module? What would be the logistics?
예, 데이터 센터 관련 질문 아니지만.
Well, thank you for the question. The Florida Aquarius, they use the floating DDL to get the power, and the pressure. There's no chamber because the pressure is basically the water pressure, the underwater pressure. But as I mentioned, the model that we're thinking of, we're going to basically use the underwater cable to get the power, and we have the pressure chamber. So you have to basically dive into the water to get to the pressure chamber, and the pressure will be basically the atmospheric pressure. So nothing else to be considered. Yes, thank you. So if you have any further questions or comments, maybe you can personally reach yourself to the presenters. So thank you so much for the presentations, all 7 presenters. we really enjoyed your expertise and insights. And KIOST will stay committed to standing at the front line, to combining AI technology, to all the oceanic research and studies. And thank you for your patience and interests, for sitting through the session. And this is the wrap of the KIOST session. Thank you very much. Thank you very much for the moderation. And I do believe that KIOST will continue to be a leading force in identifying new source of innovation and new platform for creating added value in marine industry and technologies. And there's an epilogue session awaiting us at Crystal Ballroom A. We look forward to seeing you there, and thank you very much for your support. And we have a group photo session, so we'd like to invite you all to the stage. We need a photo to publish a great-looking book, so we need your support. I really want to invite all of you onto the stage for a commemorative photo. Thank you.